Hi, good morning. Thanks for coming around. So I flew in from Tokyo, and I started a company called Shiroyagi, which is White Goat. We provide the iPhone and Android app for news creation, and we also develop a content discovery platform. My background is in physics, and I worked with the LHC data just a little before the Higgs was found, but I did a lot of data modeling for estimating the statistical uncertainties for Higgs discovery. Just wanted to give you a quick shout about PyData Tokyo, which we started last month. So if you are ever in Tokyo, please let me know, and maybe we can find some interesting events or whatnot. So this is the kind of thing I used to do when I was a physicist, which was to build a model of what we would expect in data. And it was highly confirmatory, let's say, very highly theory-driven, and you would build all the parameters into the graphical Bayesian model, which enabled you to estimate the size of the uncertainty that is in your observation. So this little bump right here in the middle, is it good enough to call a discovery, or just mere fact that you don't have enough samples? And I'd just like to introduce a very unknown framework called Root, which is a little like R, but developed by particle physicists basically. Has this Python binding called PyRoot, and gives you access to all statisticals and minimization algorithms and so on. Actually quite useful, but very little known outside of the physics and particle physics industry. So that's the package that I used to develop for. I also like to introduce who I did this work with, Hide, who didn't make it today, but an interesting project that he works on is a Mars surface project. A little like, no, actually very unlike the previous talk, but he also deals with data that is published by NASA from space, and he searches all the pictures from the moon and the Mars and uses deep learning object recognition algorithm to find signs of extraterrestrial beings. This is one that he has found in the middle. Basic idea is that he feeds in a lot of recognizable objects into deep learning algorithm and search for those things on moon and on Mars. So what we worked on for this time is something related to this news article that we provide, which allow you to follow any specific interests of your choice, and we collect news articles for you. Something as specific as deep learning or Internet of Things, we have about 3 million topics to choose from, and that's why we do mainly natural language processing as core development. But this time around we dealt with this problem that we have to do with cutting out thumbnails out of images in the article. So on the left we have an article that's about cat reacting to seeing a dog for the first time, but obviously you cannot see the cat in the image. It's cut out in half. If you see the picture in the left. One theme that is quite popular in Japan is animation, and you can see also here that the picture is cut out in the middle of the face, which is not very great for the experience of the reader. We get something like 100,000 articles every day, so we cannot do the thumbnailing by hand, and that's when we started thinking about this process. So we have the image, and we wanted to identify the interesting regions of the image by using something called deep learning, which I will be introducing, and deciding which regions of the image has more going on in terms of interestingness to human. And eventually finding out which part to cut out. So Python has been great in putting everything together. One part of the algorithm was written in MATLAB, which I had a lot of trouble installing, and then the second part was C++, but fortunately there was a Python wrapper for that, which I was successfully able to incorporate into my IPython prototype and eventually Python script. So I also acknowledge that this work was heavily influenced by the Berkeley Vision team. You should really go in there if you're interested in deep learning. They have everything on their website and a lot of examples in IPython notebook. Okay, any questions? No? Okay. So the first step in identifying the interesting regions in the image is detecting which part to look at before even being able to say what is in there. So for these two pictures that I showed, this red part was cut out by our default strategy, which is to take out the middle part, which is obviously not very clever and what we wanted to improve on. And the standard procedure for identifying the subset of the image that might be interesting was called sliding window, which is basically to do all possible size, position, and scale and aspect and search over this four-dimensional space of possible windows, which typically generates tens of thousands of windows. And if you're going to run something like deep learning, which takes a long time to run, that's definitely not a method of choice. Instead, lately, breakthrough has been reported in the sense of segmentation. So instead of just choosing randomly all possible things, you cluster the patterns of image into segments, and you can see there are four levels of segments as found by the algorithm, and each segment will generate one square. So please feel free to stop me if you have any questions. So this typically generates like 200 to 300 regions per image. Not very time intensive process, probably a few seconds, so not terribly fast, but not terribly slow either. As I said, this was implemented in MATLAB, which I had a lot of problem installing at the beginning, but then we decided to run that as a sub-process code from Python and picked up the output from SciPy.io package. And that defines all the possible regions like this, about 200 of them in these cases, and you can see they are overlapping regions in different shapes and sizes. The second thing we wanted to do was, yes please?
Sorry, I'm assuming these regions are randomly generated, or how did you?
So these were generated from this process of segmenting the image. So this is one segment where the color is the same. So in terms of color, these are all similar, and it's decided to be coded as one. Yes.
Does region selection have any input yet from knowledge base? Is it just geometrical?
This is just geometrical. Yes. Yes.
What type of features are you using in order to kind of group those parts? Like, is it only color, or do you use also like edges or some other attributes in the image?
I believe it is just color, and most simple. There are different features you can feed into this algorithm. We chose to use the most basic feature at this point. Yeah. Yes.
Isn't grayscale better than color?
Sorry?
Grayscale, black and white is better than color?
color generates more number of windows and grayscale much less actually. This research is typically done on getting a higher recall than precision. So with color there's more possibilities of segmentation, so that's why you tend to get more. Not necessarily better in the sense of getting better out of many, but it does, the chance of you getting the right one increases if you have more dimensions of segmentation. Am I answering your question? Yeah. So who knows about Kaggle? Yes? Yes? Yeah, so there was a competition on telling a cat from a dog, and you know, the top people here are like 99% accurate on telling a dog from a cat. This is probably one of the most important things you should be able to do on the internet. And it turns out all the top people, according to the discussion that I saw from Kaggle, are using deep learning nowadays, which is really impressive. But I don't have much to say about the theory and methodology behind it. But most of the work, current best work, is based around convolutional neural network, which basically convolutes pixels of the image in several steps. And towards the end of the step, it's really not recognizable. But from the experience, it does give you a very high precision. The great thing is that the library is open source. What we use is Caffe. So not everything is open source, but Caffe is known very well because it's open source and developed very actively. It's based on CUDA, C++, which means you can use it on GPU just with a single flag. And what's more useful with this is Caffe is just a framework to define neural network. So you can start to build your own, insert and remove any type of layers, but you have to train that neural network by yourself, which means you're going to need a lot of images with annotation. For example, if you're going to train on dogs and cats, you have to have a number of pictures of dogs and cats. Here, they can give you pre-trained neural networks published on GitHub in this case. And what we used is what was trained on 2013 ImageNet challenge. So the way it works is you have the network definition file and the trained network, which subsequently allow you to do the recognition. So this is how we were able to set it up through the Python binding, which we used, provided by Berkeley Group again. And you can just, the first thing on the list here is the definition of networks. So it defines how many layers and what types of layers are in the model. And the second thing and third thing basically is the result of the training after running on so many images that was provided for this competition this time. And we fed in the windows that we generated in the first step, which was about 200 of them, and it's actually a quite slow step, but you can start to see that you're actually able to identify, if you can see, this is in the order of best match. So number 0 was very clearly identified as domestic cat, and domestic cat with a wall apparently is a skunk. There's a few rubber erasers and rubber band-aid and things like that, but you know, much lower probability of identification. So that seems to be very successful in this case. The other image also pretty impressive, that you can identify person as well as tie and face powder on the face apparently. So that also is identifying things pretty clearly.
What scores are these? I'm a little confused about the numbers.
So these can be interpreted as probability if you put it in exponential.
Okay.
So log.
This is not terrible, it's just
It is a smaller number. Yeah. So minus means minus. I mean, everything below 0 is not very good from our experience, to be precise. Yes.
Can you go back one slide? So the interpretation of this would be, the exponential of this would be a probability. Clearly 1.03 would be higher than 1.
Is this like a log probability?
Yeah, so log of probability is what this is. So if you put this number into exponential, I don't remember what the base of the exponential was, but
okay.
yeah.
It's not e something.
Yeah, right.
Okay. All right. Cool. Thank you.
Okay. So the next step was very simple. You basically add everything up. We tried just selecting the top few areas as compared to all the areas, and you can really also cut on like the probability, for example, to get just the best areas. At this point, we're just taking all windows and just let the small probabilities be in there because they won't really highlight that much anyway. And you can see that the red region there on the left is for the cat, and the right region you can see the faces and the ties and the face powders highlighted as red in there. So the final step is to crop the images. Basically, we had that window size 2.5 times 6.3 was just a size constraint that was given by our UI designer. We also have square shape thumbnails, which we didn't try at this time, but it works all the same. We basically generate all the possible locations for the windows that we want to cut out, and then calculate the sum of the probabilities that is in there, which means selecting the square that is containing the most amount of interesting regions out of all the selections, and that eventually led us to choose the parts that is incorporating the interesting region, as opposed to what we were initially doing was to pick up the center region. So this has been successful. With some things it's not. This was taken from an article about a guy who was growing pot and busted later on or something. And you see, with this picture, with the window size that I had, you can only capture the face part or the cannabis part or any other part, and that definitely needs to be improved on. You can choose different aspect ratio, and we don't have the way of doing that as yet. Although we can see, like, using different size, aspect ratio, and compare the score between the two, can conceive of which one to select on. Magnification is something we haven't tried, so we assume that the side of the cropped image coincides with the short side of the initial image. You can obviously do better on that by selecting the regions that have higher contents of interestingness. Although with this you need an extra constraint in order to stop the square from shrinking too much. If you're just increasing the density of the interestingness, you would tend to get just a very small region with the high score. So you need to apply extra constraint in order to find a relatively large enough region. And there was a comment on, most of these interesting things were people and cats and dogs, and typically those things. So right now we're using 200 category deep learning algorithm, which is just way too complex. There are things like, as you saw, like rubber band and bandit and things like that, which we typically don't have in these images anyway. So you might as well just do face and human recognition. Although for some things accuracy would definitely decrease. And with the machine learning algorithm, unseen objects are not treated very well. But it might be misidentified as something else, but really the probability of something unseen identifies something else is very, very low according to the output that we're getting. So with these things, you can fall back to just using those geometric features instead of doing the object identification. Although we haven't, at this point, we haven't really tried that. Yeah, so also human is probably more important in this picture than the plant. So that kind of decision can be written into the code by hand in order to prioritize some of the more interesting things to give better result. Yeah, so that's all I got for today, and thank you very much for listening.